Hey everybody, welcome to Notes H, section 3.1. Let me just start out by saying that you might want to look over the first few pages in that section just to kind of get some background about where we're heading with this lesson. So, yep, this is Notes Video H. All right, the topic is going to be finding extrema on a closed interval. And those words are important. We're going to find extrema, extreme values. Okay, something else you might want to consider is that this means we're going to be finding absolute maxes and mins. Absolute max and absolute mins. And when we talk about finding extrema, or absolute maximums and absolute minimums, we're talking about the y values. Okay? The answer to the question of the extrema question is the y value. So you're going to have to locate an ordered pair, a point. Okay? But when you go to report the answer is just going to be the y coordinate. Now, will it be wrong to give both x and y? Certainly not. But by you just reporting the y value, that's telling somebody that you really understand that an absolute extrema, whether it's a max or a min, is the y value and not both the x and the y coordinate. All right, closed is another important word too. When we talk about a closed interval, we're talking about, not anything like infinity, negative infinity or positive infinity. And through our work, I'll try and make a connection back to these words. All right, there's a set of steps that we're going to follow in finding our extrema. So again, remember, extrema, when you read that, could mean absolute max or it could mean absolute min. Those words are all interchangeable. All right, the first thing we're going to do is find the critical numbers. Critical numbers. Okay, well, you're probably thinking, well, what's that exactly? We're going to find the critical numbers of the function in an open interval, because of the parentheses, a, b. Okay, well, the critical numbers are the c values, or if you will, x values, the c values at which the function, at which f prime of c, okay, has a horizontal tangent, that's f prime of c equals 0, okay, or it could be where the derivative at 0 does not exist. Oh, I'm sorry, not 0, the derivative at c. All right, so these are the x values or the c values on this interval where the slope is 0 or the slope does not exist. And just to get you a real quick visual, that could be at a min max, a flat spot, or it could be at a sharp turn. All right, so we're going to find the critical numbers. So we'll look at that step in a minute. Evaluate the function, the regular graph, at each critical number. That just means that once we find these c values, we're going to plug them back into the original to get the y values. All right, step 3. Evaluate the function at each endpoint of the closed interval. Note the brackets as opposed to the previous parentheses. Okay, then we're going to take each of the endpoints and plug them into the original function. We're going to create a t-chart. The least of these values is the min, and the greatest is the maximum. Okay. All right, so that's the explanation of what we're going to do. Now let's actually go through and work a few problems together. All right, you can see that I've referenced this to our textbook for 2 particular pages. So I'm just still in the author's example. We're going to be asked to find the extrema. So right there, we have to know, what does extrema mean? We need to find absolute mins and maxes, meaning we're going to have to follow these 4 steps to do that. We're going to find the absolute extrema of this function on this closed interval. Well, first thing I want you to notice is that -1 corresponds to our a value. It's our beginning x, if you will. Okay, and 2 is the ending x. Okay, so a is -1 and b is 2. Okay, I think to help us with our work, it would be good to have a graph. So what I'm going to do is the best that I can. Over here, I'm going to provide you a graph of this 4th degree function that opens up on this closed interval. So you can follow along. You can type this into Y1. You can go to your window setting let x min be -1, let x max be 2, set a pretty good y window, min and max, to view this graph on this closed interval. I don't want this whole graph, I want this closed portion. Okay, so what does that graph look like? Well, when I graphed it on my calculator, again, remember this is -1 and this is +2, and it's a 4th degree function. It actually came on my screen about right here, and it looked like it kind of flattened out right here at the origin. Okay, but then what happened was I could see that it dipped below a little bit, kind of flattened out, dipped below, and then it came back up, and then went off the screen probably about right here, a little higher than this place over here. So like I said, you might want to pick up your calculator and kind of simulate this graph, but this is the graph, the piece of that 4th degree function on this closed interval. Remember, this is A and this is B. Okay, well, what we're asked to find is the extrema. Okay, so what's the highest y value? Well, the visual shows us that this is going to be the highest y value. What's the lowest y value for the other extrema, the absolute minimum? Well, the lowest y value is going to be about right here at this minimum where the graph dips down and comes back up. So, all right, I see that. I can find that on my calculator. Without a calculator, these are the steps we're going to follow to verify that this y value and this y value are our extrema. So step 1, find the critical numbers. Okay, well, let's find the derivative. First step, find the derivative. Easy enough. Polynomial function, well-behaved, continuous, no sharp turns, easy function. All right, so to find the critical numbers means set the first derivative equal to 0 or find where the first derivative does not exist. Well, I look at this derivative and I'm going, well, every x can work in here, so I know the derivative exists at every c value. My next move is to set it equal to 0 and find the x's that make it 0. So let me factor out 12x squared. And I'm left with what? X minus 1. All right, so at this point, I see that x equals 0 or x equals 1. So these are my two critical numbers. So let me just kind of share some notation with you. What does this mean right here, what we just found? Well, we found that f prime of 0, this 0, when plugged in here, would give us 0. We found that f prime of 1, again, when you plug 1 into the derivative for x, you get 0. We found that these are the two c values, if you will, where the derivative is 0. Okay. And just another point right here for you to be aware of. You don't have to write it, but f prime actually exists everywhere. So when we talk about critical numbers, here we just have two numbers, two critical numbers, c, the c values at which the slope is 0. Okay, so there's not a c value where our derivative does not exist. I know that's a little abstract, but the first step here is to find the derivative so we can get critical numbers. These two right here are our critical numbers. So you can call those CNs if you want. Okay? Step 2, evaluate the function, okay, at each critical number. Okay, so actually what I'm going to do over here is I'm going to begin to create a T-chart. So I'm going to do this work first, and then I'm going to come over here and I'm going to create a T-chart. I'm going to look at a T-chart with x for this function and f of x. Okay, and so what I'm going to do is I'm going to put any of my critical numbers, my c values here. Okay, and then I'm going to put my endpoints here too. And the endpoints of my function are -1 and 2, the x values of my endpoints. Because this is really step 2 and 3 together. Evaluate the function at each endpoint or each critical number. So what's f of 0? Well, go to the regular function, plug in 0, get 0. Go to the regular function, plug 1 in, get -1. Evaluate the function at -1. When you plug -1 into the original function, you get 7. And f evaluated at 2 is 16. So find the critical numbers. I did that. Evaluate the function at the critical numbers. I did that. Step 3, evaluate the function at the endpoint. Well, those endpoints are right here. I did that. Okay. Just want you to happen to notice that all the integers are here, but that's not necessarily true. That just happened with this problem. Step 4, the smallest of these values, a value is a y value, is the minimum. The greatest is the maximum. So we're going to come over here, and from this information, from this t-chart, we're going to focus our attention on these values. So I'm just going to say the absolute min is y equals -1. Now you could say when x equals 1, but the true answer to this problem is the y value. You could say the absolute min is 1, -1 and give the ordered pair, and I'd give you credit for that, and you get credit for that on an AP test. Okay. But as said earlier, an extrema is a y value. So by you reporting the y value, you are telling somebody that I really understand what that question's asking me. The absolute maximum is y equals 16. You can put when it occurs when x equals 2. So let's look back at our picture, because we just did a lot of work here, but let's look back at our picture. All right. Our absolute min is y equals -1 when x is 1. That looks like it's occurring about right here. And that confirms with what I'm seeing. The absolute maximum is 16 when x is one of my endpoints. And that makes sense with what I'm seeing here too. So in order for us to find an extrema, an absolute min or max, okay, those are going to occur on a closed interval, either where you have a 0 slope, because think about that, you're either going to have a max or a min, or possibly a flat spot. Okay? But your extrema are going to occur where you have 0 slopes, do not exist slopes, or it could be at an endpoint. Here the minimum occurred at an interior point, but the absolute maximum occurred at an endpoint. It could be any combination of things. As long as you kind of are following these guidelines, you should be okay. All right, for our next example, you're going to be asked to find the extrema on this cubic graph on this closed interval. So again, remember, this is your A value and your B value. Oops. All right, I think the best thing we can do right now is just produce a graph of this in our calculator to get a visual of what this looks like to help direct our analytical approach. So I already typed it in on the calculator. I did type that in as y1. I did let that x min be 0 and x max be 4. I had to adjust my y min and y max to 20. Okay, so this is what appeared on my screen. I encourage you kind of follow along with me too. Okay. The graph really dipped far below the x-axis. Okay, and then what it did is right before 4, because remember this is the closed interval 0 to 4, right before 4 it came back up above, had an x-intercept, and then it went off the screen. Okay, something like this. So that's kind of the appearance. So again, remember the objective. We're finding the extrema, the extreme values. Not that I meant to, but this particular graph looks somewhat similar to the previous graph. So let's get an idea of what our answers are going to be. As I study this graph right here on this closed interval from 0 to 4, I notice that the absolute minimum is going to occur down here, and the absolute maximum is going to occur at this endpoint again. And like I said, I didn't mean for that to happen to be similar to the other one. But it might be a good idea when you guys are doing your homework problems to at least graph the equation on the closed interval to have an idea of what your answers should be. All right, let's find the extrema, okay? So let's find the derivative. And just also noticing, again, we have another polynomial function that's well behaved. It's continuous everywhere, and that's nice. We know the derivative exists everywhere. So the only thing that we could possibly find are the points, the x coordinates where our derivative is 0. So I'm going to factor out a common factor. Okay, and then from this I know that 0 would not equal 3. And then I know that I'm going to solve 0 equals x squared minus 4. From that, I know that x is going to equal positive or negative 2. All right, so the notation. So these are my c values that are going to go inside my t-chart. But just to pay attention to the notation, I know that f prime at 2, when I plug 2 back into the derivative, I'm going to get a 0 slope. I also know the other critical number, f prime of negative 2, is going to give me 0. So we say that 2 and negative 2 are our critical numbers. Building your t-chart, I'm going to start by putting my critical numbers in here. So I've got 2 and negative 2. I don't care that they're out of order. Okay, and I'm going to evaluate the function at those critical numbers, but I'm also going to evaluate the function at a and b, my endpoints. Okay. So notice that these x values right here, they don't all cover all the integers from negative 2 to 4. Don't start with the endpoints. What I've seen in the past is some students will put 0 to 4 and put all the numbers in between 0 and 4. Well, you know, that doesn't have to be the case. All right, you might have noticed also right here, this critical number of negative 2, I'm going to save myself some time. Notice that negative 2 doesn't fall in my closed interval, so I'm not even going to evaluate the function there. If you notice that negative 2 fell outside of your interval up here, then don't even include it here. All right, real quickly, going back to the original function and plugging in each of these x values, one of which is a critical number, the other two are endpoints. F of 2 is actually negative 16. This one's going to be 0, and this actually is going to be positive 16. So step 4 says, well, just pick the smallest and the greatest, and there are your extreme values. So the absolute min is at y equals negative 16. And you can say when x equals 2. And the absolute max is at y equals positive 16 when x equals 4. So this is my preferred method for you to write that statement right here, as opposed to an ordered pair. So if you would, and then please include when and at what x value. That would be super. Okay, so again, going through the steps of how to find that, find the critical numbers through the derivative process, set up a t-chart, evaluate the regular graph at those critical numbers and the endpoints, and then verify with your graph when at all possible.